Hello, hello all. Awesome. So I'm getting confirmation you guys can see me. There's probably going to be a little bit of a pause. I wanted to make sure everything came through. Sounds like we have some audio problems. Can't quite hear me. Go ahead and put a message in the chat if you can hear me or if you need me to turn my volume up or something of that nature. While somebody's doing that, if anybody is out there, we're going to go ahead and warn you guys there is about a 40-second delay. Awesome. Looks like Jeff just messaged in saying afternoon. Awesome, Jeff. Great to see you here. There is about a 45-second delay, so if you ask a question, you're going to notice that it's going to take me a moment to get to it. By all means, feel free to do anything inside of chat. I also have Umair here. He's one of my specialists on top of that. He would be able to answer some of those simple questions as we move through this. So I'm going to go ahead and dive into this a little bit. Let's go ahead and start from the top. Right here, you should be able to see over my right shoulder. Yep. We had a last minute sponsor come in that actually creates these quad rail, or I shouldn't say quad rail because it's not a quad rail extrusion. It's actually just a handguard extrusion blank. Great company. They reached out to us. They went ahead and said, hey, we have this design open to the public. We also are selling these by the foot. A lot of that information is down inside the menu below, but this is the drawing we're going to start with. And depending on our time frame, I'm always happy to circle back and look at doing a quad rail just because that was what was promised. So let's go ahead and jump into this a little bit here. So at this point, you all should be able to see my screen. Again, there's about a 45-second delay by the time you see this and what I'm doing. But let's start from the top. So I've already opened up Fusion 360. I started a blank file. So the first thing we want to do is go ahead and save a file. We want that hard marker to start from in case something was to happen where we lost power, or you never know, maybe the program shuts down. So we're going to go ahead and say this is our SHOT Show handguard. And with that being said, I'm actually going to do a little trick here. So normally I would have the drawing pulled up on another monitor, printed out, sitting in front of me, but I'm going to go ahead and insert a canvas. What inserting a canvas is actually going to allow me to do is bring in a photo of that actual handguard. So I used Windows snipping tool to come in and snip a screenshot of this so that I could directly import it. It's also going to allow me here is to go ahead and scale. So I'm going to go in and I'm going to calibrate. And I'm going to calibrate off a known dimension. So I have a lot of dimensions here I can pick from. Mainly, I like this one right here. So let's go ahead and pick our 2 points, type in our dimension, and now you're going to see the scale of this item actually scaled up very well. You're going to notice I'm a little off from my origin. Not a big deal as we start to draw this. We can always move it later or leave it right where it's at. So the first thing I'm actually going to do is I'm going to create this stock of the extrusion for Umair, my counterpart, to actually use later when he's machining. And this is going to give us a really good rough outline based on that for designing a handguard to go into manufacturing. So I'm going to go ahead and start my sketch. We're going to go ahead and pick our plane. And the simplest thing I could do here right out the start is probably create my center circle, where if you've seen our other actual live stream on the barrel nut, you would know that this dimension here is what we're looking to match. So we're going to go ahead and just walk through creating some of these dimensions. Given that this part is symmetrical left and right, and we have a center line here, I'm actually going to create that center line based on that actual profile. So let's go ahead. We can over-exaggerate this and drag it down. I'm going to go in and use a constraint called horizontal vertical to actually place my points horizontal vertical so that that line is perfectly vertical. As you can see, I'm getting a warning because it's already seeing the line as horizontal and vertical. So things don't move around as we continue to design this part out. I'm going to go ahead and actually use a fix, and I'm going to fix that center circle so nothing goes moving around. The nice thing is as you can see, I haven't added any dimensions to the overall length of this line. So I have that freedom to move it around to get closer to the shape I'm looking for. From here, I'm going to go ahead and use a couple of simple rectangles to just draw out this rough shape that we can come back to later and dimension out. So we have that upper rectangle, lower rectangle. We're going to utilize a line. And very simply, we're just going to walk around this part, recreating this profile from that photo. So we have that upper profile, lower profile. Lastly, we're going to go in and create this actual key mod section. I shouldn't say key mod, Picatinny section, correct? That, to be said, is we do have some lines that are a little skewed. I can now go in and I can actually, again, use things like horizontal, vertical to match those up. I also know that the dimensions here that we're reading on our print, 021, I can start to dimension this out and create that precise profile that we need. So there's our 021. We also know to the top of this point, from the top of our actual Picatinny rail, that is going to be 0.1. We know our angles here as well. This should be 90 degrees. So as you're seeing, I'm over constraining my sketch. This is always fun when you have this happen to try to go back and fix it. But what's actually happening is these are actual perpendicular to one another, which is causing that, which actually already tells me that they're set to 90 degrees. So again, we could add a few more of our dimensions. Everything we are doing is a half dimension. So if we know that's supposed to be 0.855 divided by 2, we could actually type in that math as we go. Again, pulling our next one, which would be from this point, 656. And as you're seeing, I forgot to divide by 2. Not a big deal. We could always double click that dimension and divide it by 2 to bring it back. Last one's going to be is the fact that we have our flat down here. That's going to be 0.617 divided by 2. And now you can see as we're dimensioning this out, a lot of our constraint dimensions are starting to blacken out, causing those profiles to be what we need them to be. So again, we can add a few more dimensions here. We know that's actually going to be 60 degrees, or actually I should say 6-sided as a hexagon. So 360 divided by 6, which is going to actually put us down into the 135 degree. Nope, I'm a little off here. So it'll actually be 120. Oh, I'm still off. Look at that. So cool thing is as we play around with this more and more, we can either make guesstimates or we have that ability to go in and actually do the math and say 360 divided by 3, or actually not 360 divided by 3, but divided by 6. And then we could throw that into brackets if we wanted and then get our dimension from there. So we're getting 60 degrees. We probably need another 60 degrees added to that because it's external. Again, we could either take that divided by 2, or I could actually say that's 60 degrees. Again, I'm making mistakes out the hole, a little nervous for those of you watching at home, and get that angle right. So again, we're going to go ahead and play with this a little bit more as time goes on. I'm going to go ahead and delete this dimension, and we'll come back to it here in a second. So we're going to go ahead and get this back to where we kind of placed it. I'm going to do a few other dimensions first to kind of clean up this profile. So we do know from center line 1580, 1.580. And again, we forgot to divide that by 2. As you're going to notice is some people say that I'm a fusion expert, but I still make those beginner mistakes all the time when it comes to making these profiles. So knowing that that actual dimension there from the actual center line out to that flat, it's going to be the same dimension here for my 2 other sides of my flat. So I could go in and I could actually say those guys are equal to one another to balance that out. And I could also undo that given the fact that I don't want those equal because it looks like this guy up here is a little different at the end of the day. So again, we have a lot of different dimensioning we can do to clean up that profile. I'm going to go ahead and go to another little area and sketch this out. So again, we can go ahead and create that next profile inside there for our actual gas tube to pass through. We also have an angle inside of there. So let's go ahead and make that angle. And then we could actually add those dimensions in just as it's shown. So the nice thing here is as we're creating this profile and doing everything, is we're basing this all off of pre-created dimensions from the supplier. So if you were to do your own custom actual extrusion profile, you can order dies through a company like our sponsor, And what they can do is they can cut those dies and run just about as much material as you like at the end of the day. Or you could actually utilize the profile that we have here, and they will actually ship that to you at the end of the day. So again, we're going to go ahead and check a few things here. Let's see what else are we missing. We're actually missing our dimension down here. So we got 420 divided by 2, kind of a funny number some days, right? Again, off our center line or our overall height here, we got that 2.382. And now that being said is we have that upper dimension. Again, we can continue to dimension this, but I don't want to bore you all to death with how you would create these profiles. Again, we could actually add those dimensions in for that angle. We have that driven dimension because again, as it's trying to pull a constraint of parallel to the flat up here. So again, as if I click this constraint here and this constraint here, we're getting that parallel across the two. The same thing would apply is this line here is not actually parallel to anything. So that would be one that, again, I could actually change or add a dimension to. So let's go ahead and turn off our canvas. And utilizing this profile, we're going to go ahead and we're going to extrude this guy out. So we're going to go around and we're going to pick that profile we just created. And we can go ahead and make that 12 inches long. So what a lot of you are probably going to ask yourself is, well, you've only done 1/2 of that extrusion profile. And I would agree with you 100%. However, what we can actually do with that extrusion profile is knowing that it's symmetrical is we can mirror the body across our center line flat and join the two automatically, creating that extruded profile. So that being said is we can go ahead and save this again. And that allows us to create our raw material for Umair to work off of here a little later when it comes down to time to actually machine these out. What I'm going to do with this is I'm going to open a new file, and I'm actually going to insert that piece of raw material into my actual part. So as you're going to see, I failed to save, which is more than easy enough. So here is our handguard design. And now we're going to bring in that raw material to start everything off of. So again, is we have that rough profile that we've started with, and that's going to be our stock that we're going to actually concern ourselves with as we make the actual handguard to make sure from the extrusion to our design, we have plenty of room to work with. I'm also noticing here is that I failed to make some fillets in some certain spots. So I actually have that ability to go back to my original handguard here and fix that. So let's go ahead and kick that canvas back on. And we could actually rotate this to be backwards, but it looks like I failed to fill it down here at the bottom at 0.20, and then I failed to fill it up here at the top at 0.63. So let's go ahead and add those real quick before we get into designing the other part and profile. So again, we know these are 0.63, and then we also know down below, in this case, I got a little happy with the old edit and hit enter. I can actually add those all into one feature in my design tree. So again, we're going to go back. We're going to add in now, is that 0.20 or am I just reading it backwards? It's 0.60. So let's go ahead and type in our 0.60. So again, even though I've missed stuff along the way, I have the ability to go back and edit it and add it in to make sure that we get the most up-to-date data going into our other side of things. So again, when I hit save on this guy, what we're going to do is we're going to see that save in our data panel. I'm going to go ahead and close out that data panel, but let's go back to where we're trying to design. I'm now getting a warning based off that, and that warning is that, hey, the design has changed. You need to bring in the latest and greatest. This is very handy when you're rapid prototyping or working with other CAM softwares and bringing your designs through Fusion. As you can see, when the design has changed, fillets being added down here at the bottom, as well as where our gas tube sits, it all came through automatically with what we're doing. So this time you're going to notice that we're going to do a little bit different workflow. I'm actually going to create a component in here. And what that component is going to be is the handguard itself. So if you kind of think like modeling clay, we're going to more or less whittle out this actual profile based on what we have. So again, we're going to define the parent as being the upper level. And as you can see, it activates and it almost ghosts out my image of my handguard blank. But now we can go and pull from this profile, right? So let's create our sketch on our face. And now we actually have an automatic projection of what to work with. And we can go through, and again, is 100% here, create your center line because we're going for symmetry, left and right. And then we could start to build out these profiles that we know are actually going to be undersized based on the real specs of whatever you pull online at the end of the day. So I'm going to just very simply create that same kind of profile around as if we were going to cut this with our actual CNC mill. So we know we're going to clean up those edges all there. From there, we have the ability to also clean up the bottom if we want to change that profile. Anywhere we want a machine to actually clean up, that's where we're going to actually create the profile. Again, we're going to utilize this from a straight on view, and I could actually do an offset here to speed up the process, right? So if I wanted to take the entire profile and clean up everything by 15, go ahead and type that in by a negative, and now you're going to see we created a 15th thou skin to take off of when we're machining. That being said, is we wouldn't use that initial sketch that I created. I could always delete that, or we can leave it for now because we can pick those profiles individually. So again, just like we did the first time through, we're going to grab that actual profile. I'm going to go ahead and extrude it down, and let's just go with a 8.9 inch handguard, right? So in this case, we're going the wrong direction. I can type this in as a negative, and you're going to see we're going to go back the other way. So I have my blank versus my machined actual part, and that's what we're going to utilize for anything that we have going on. So as you're going to see here, I'm just holding the control key down to pick those couple of profiles from our initial sketch to generate that first iteration of the handguard that we want. So let's get our stock out of the way. We're going to repeat, again, the mirror idea that we could take a left and a right, but I'm actually going to wait to mirror this. And the reason why I'm going to wait to mirror this is I want to start doing things to this actual finished product so that when it comes time to manufacture it, when I mirror it, we carry all features across the handguard. So a few things I'm going to start with is I like the idea down here at the bottom is we're not actually going to keep all that material at the bottom down the entire length of the part. We may actually just keep that profile down the length and then leave a little bit of section for us to add a few bolts to clamp this onto our barrel nut. So I can actually create that. And again, you're going to notice that I'm a big fan of rectangles at the end of the day. So we could go ahead and create that profile that we want to keep. I'm going to add my dimensions there as well. So let's say we're going to do 1.75 to start. And now with that, I'm going to create one more rectangle, and this rectangle is going to actually go down the opposite way so that when it's time to create that profile, I can now extrude, not a surface extrude, but a solid extrude, and I can cut off the bottom of that actual handguard extrusion. So now we can go back and we can do a few other things like add a few fillets in here to clean up this design. Maybe we add another fillet up here at the top. I don't want that fillet to go all the way around, so I'm actually going to turn off chaining and just pull this one little edge. Again, up to you how crazy and how custom you get with your design and what you're really going for. I'm just going to keep it relatively simple for right now. But again, what we're looking at is if I go ahead and pull up the slide here, it might be a little tricky to see in the background, but the profile that they use up here at the top, I apologize, my green screen here is getting out of the way. You can see how they use those 3 bolts to clamp down to hold it onto the barrel nut. And that's basically what we're trying to create. There's a lot of different ways we can create this, and it's a lot of fun on how we can create it. But the main idea is let's just kind of treat it like modeling clay and get our ideas right onto our part. A few other things I might want to do is let's go ahead and create our sketch down this face this time. And knowing that I can, again, create a profile that I choose. So let's just say we're going for some 3/16 holes. And we want those 3/16 holes based on center. So we're going to go ahead and create a construction line on center. And then we're going to take this and I can free move it up and down and just drop it in place. So we know a distance that we want from the end to center. And let's just say that's 0.25. And now we can create that actual profile. So again, I used a hotkey E for extrude. We're just going to make a nice simple little hole. We're going to pattern this down the part to make our lives much easier. So again, we can go in and we can do a pattern on path. We want to do a feature. So I can actually grab that extrude and I can pick the path based on one of my straight lines down my actual handguard. So again, we want to do this based on spacing. So we can go ahead and change that to spacing. And let's just make our spacing 0.25, or is that going to get us a little close? 0.25. And actually, our start point is 0, so we want 0.25. We also want this the opposite direction, so we could go ahead and flip that by typing in a negative 0.25. And that will allow us to go backwards down our part. Oh, I apologize there. So we're actually going to change that from spacing, start point 0, and we want a quantity. So we should be able to go negative here, and it looks like I'm erroring out the software. This is the great thing about it, that sometimes you, even as a professional, run into little hiccups as to why it won't go one way or the other. So as we're seeing here is it doesn't want to do our spacing as a negative based on our path, right? So sometimes we just need to do a simple pattern that is more of a rectangular pattern on an axis. And then as you can see now when we do that, we can actually modify and pull that any direction we want. So 0.25 with a 3/16 hole is a little too tight for my liking. Let's go ahead and open that up to a 1/2 inch. And then we can add in about as many as we need. So let's start with about 20. And as you're seeing, I'm changing the wrong quantity. So let's go back to that other quantity. And we want a quantity of 1 by 1. And we failed to add spacing. Again, sometimes you just fight the battle, right? So we have 20. 20 is not quite enough. Maybe we should do 40. 40 is a little overkill by 5. So let's go ahead and drop that down to 35. So as you can see, we can pattern down the length of our part, adding all those holes in to perforate for heat loss. One kind of tricky thing that is happening, though, is if I was to actually go back to when we extruded the length of this part out, if I was to change this length to 10.9 and hit OK, you're going to notice how it actually, our clamping location has moved. However, all of those perforation holes have not been controlled with that. So again, it's one of those things that there's a lot of good in the software, but sometimes with how you design can make a big difference at the end of the day. So how we could remedy that is by using a parameter table. So I'm going to go ahead and go into the change parameter area. And with the change parameter, this is kind of a neat thing at the end of the day is we can actually look at when we did the extrude length, which is right here. And then we could also look at our pattern based on spacing, correct? And the number that we need. So we could do a little math here. So what I'm going to do is I'm going to create a user parameter. And this is actually going to just be no units, just a number. And this is going to be length, right? So now our expression is going to actually be is we want, let's just make this simple with an 11-inch handguard. And now I'm going to plug that in down here. So what you're going to see is if I start to type in length, and now I'm getting it as an error, but if I take that times a -1, as you can see, I have an 8 in there, which is why I'm getting the error. So length times -1, I apologize there. And I actually click off that, you're going to notice that the handguard barely moved. But if we again drop this down to 9 inches, you're going to see that handguard slides in. So the cool thing is with this parameter area, we could actually do math, right? So I would like to take, for 35, right, I can take length, and then I want to divide length. Let me go ahead and get my divide by my spacing, which is D15. So let's go ahead and type in D15. And now what you're going to notice is I'm having an issue because there is no inch in there. But if I take this and I throw this into brackets, we could actually fix that at the end of the day. So we're going to go ahead and say length times 1 inch, divide it by dimension 15. So what happened there is it actually dramatically reduced how many holes we created, right? So in this case, it actually dropped our divided by length times 1 inch. Let's go ahead and fix this out here. Actually, that's a quantity. That's why it's giving me that. So we actually want to do length divided by D15. And then we would like to remove that inch. So this is where I might have to create another parameter, right? So let's go back to the top and create a user parameter. And we're going to create this parameter as hole spacing at the end of the day. So let's go ahead and remove this. And we'll plug in a dummy number for a second. And let's do a new parameter. So this is going to be holes. Hole spacing. Let's do hole spacing. And then we're going to make that 0.25. So now if we go down here and we plug in hole space, you're going to notice that we can retain that 0.25, but now I can actually use length divided by whole space to get my actual integer for my length, or the distance that I'm trying to measure. Again, we may need to take this -2 and clean up that a little bit, but there's a lot of different ways we can actually utilize those measurements to set whatever it is that we're doing. Again, we have length, and in my mindset, we have a length of 9. So the real problem is we need length divided by whole spacing to give us that final number. So let's go ahead and go divide by whole space at the end of the day. So the idea was that I just needed to take everything times 1 inch. But now I could break this out a little more in depth. Again, we're going to go ahead and throw another set of brackets on this. And this time we're actually going to subtract. Let's say we subtract 2 from the actual equation. The idea is we could actually take those 2 off from either end to complete whatever we're trying to do. So again, we have whole spacing. Let's go ahead and throw this whole thing in brackets -2 and see what we come up with. So again, the idea is I'm looking to take away a couple of holes from one end or the other to even this out. So let's go ahead and try this with just -1. So that looks clean in our overall length. So now we actually have that ability that if we change to 10 inches, or if we change to 10, let's go ahead and plug in 10.5. So as you're going to see, as we update those dimensions, we're automatically driving all of our actual spacing and everything. So it's kind of neat to see that whenever one dimension updates, you can actually build out a handguard here to auto-calculate all the others. So as you're seeing that 45 went to 47, we're constantly getting a clean line. So again, the nice thing is if you really wanted to build a product line of multiple lengths here, you could do that very in, and let's create a chamfer now. So let's go ahead and chamfer the upper edge of this because nobody likes burrs on our part, right? So let's go ahead and just throw in a 10 thou chamfer. And then let's move our pattern back forward and see what happens. So notice how the chamfer hasn't continued down my part, only my actual pattern. Again, if I edit my pattern, I'm going to hold my control key and pick that second feature, which is the chamfer, and hit OK. Notice how now we're actually getting that chamfer on each and every hole down our part. So this time we're going to get a little more fancy with this. Let's go to the inside. Let's create our sketch on the inside here. I'm going to rotate us around. And again, I like rectangles, right? So what we're going to do this time is we're going to create our actual key mod slot, or not key mod. I keep saying key mod. Don't take my dimensions to heart because a lot of these dimensions you're going to find out from a little bit of research are a little off. So let's go ahead and go 201, 203, and then depth-wise, we could set this to, let's just go 190 to make it easy. So again, we know what our actual couple of dimensions here that we're utilizing. We want to extrude that out to cut it. And then we can once again pattern this down 01 plus 0.203. And then how many we need to go down our part. I think we saw about 45 the last go. That's a little too much. Let's go back to about 30. And with 30, we're actually hitting almost perfectly at our end. If I was to actually spend a little bit more time on this and do a little more designing on it, I think I would also go in again and create those parameters to really make my life easy on creating those profiles. So again, just so we don't forget, we're going to go ahead and slide our actual feature back. We always have that ability to go in. Let's make this a little more difficult on Umair. Let's give him a 030 radius down here at the bottom. I also like the idea of maybe tossing a couple of simple chamfers on this part. So let's go ahead and add in 20 might be a little overkill, but I like it. And then he can actually take that later, as you're going to see in toolpathing, and he's going to be able to pattern that. So again, we're going to slide our timeline forward, hold our control key, pick our additional features, and hit OK. So as you can see, we actually broke the edges on the top of each and every one of those, as well as adding fillets down our actual part. So continuing on, as you're going to notice, this becomes more and more kind of just over and over again patterns in some full length here. And let's use a rectangle from center. And again, I could actually go in and generate my key mod slots. I'm not going to get crazy on the dimensions here, but as you can see, we could actually create the key mod location for where you would want to mount. I created that sketch very quickly on that face. I'm going to go ahead and break these corners in just a little bit. Let's throw in an 0625. And again, we just patterned. So this is going to become more and more repetitive, which a lot of people at the end of the day, once you see this the first time through, it's very shocking because you're like, wow, I didn't realize on a symmetrical part how much stuff we could do. So again, we're going to go ahead and say this is symmetrical. So we want one on both sides. If I did give this a dimension, we would be a little more precise with those dimensions. In this case, let me go back. I went ahead and fat fingered the keyboard. So we're going to go and pull that extrude and fillet. We're going to pull that based on an axis, and then we're going to do symmetrical again. Let's see what 2 inches looks like. Let's bump that up a little bit. Maybe we'll space that out closer to 2.3. That actually looks like pretty decent spacing. Again, with a little bit of research, a lot of you will find that you're going to actually get those true dimensions and place them where is needed. So that being said, again, I hate to do it to you, Umair, but let's go in and let's give this a chamfer around the upper edge. Again, we just want to make this part nice and clean and also a little bit of a pain to actually create. So again, I created that feature. I failed to do it the first time round. I now go back, I add it back in. So I'm not seeing very many questions in the chat, which is more than okay. If you guys do have any questions or any curiosities, feel free to post them in the chat. So at this point, let's give this a little bit more decoration before we go ahead and mirror it across. So from here, we're going to create that sketch on the face. I'm a big fan of the old circle, triangles, and squares. You can make up whatever you want at the end of the day. But as you're going to see me work through this, we're just going to create our center line all over again. First one in my book is going to be a circle. Then let's create a rectangle. And then lastly, we're going to go ahead and create a triangle based off those couple of profiles. So as you've seen me do this, I did it very quick on this face. Let's get rotated around here to get a little better idea. So first and foremost, I need to set some dimensions again, right? So let's say we want a 3/8 circle, which means I also want the dimensions on my rectangle the same. And then I'm probably going to actually do a couple of triangle to look the same size. So if I double click this dimension and click my first one, we could tie those two guys together. I can also do an equals here to equal my two sides together. So now the vertical and the horizontal is the same length. And then from there, I'm going to go ahead and set my horizontal vertical because I would like this uppermost part. Let me back that up using Control Z to be the top point, and then my bottom be the same as the bottom of my actual rectangle. From here, I know that's an equilateral triangle. So we're going to equal all three sides together to even it out. And then lastly, what I'm going to do is I'm going to add some dimensions, right? So what is my spacing between these two? Let's see what 0.5 looks like. Looking good. Spacing between these two, probably could get away with the same. And then my spacing from the end. So again, depending on where you want to start your actual handguard, I'm going to scoop mine back to 1/4 inch and then create everything based off of that. So let's go ahead and finish that sketch. Again, we can extrude that profile down into the handguard. And then this time we're going to do fillets on the front half just so that we don't have to keep rolling back that timeline. So again, we're going to throw some 0625s in here. Might throw in some 031s depending how it looks. So again, we're picking each one of those edges internally. Let's go 0625. As you're seeing, it's a little bit of a crazy triangle. Maybe we need to go 03125. That looks a little bit like a better triangle at the end of the day. So I'm liking that in its shape and design. So we're going to go ahead and run with that. So again, let's throw some chamfers on here to really make everything painful as we can. I don't have to machine it, so it's not a big deal. And now we have our features built. So now again, we just repeat our pattern process, right? So we're going to pattern the features. We're going to pick our extrude, fillet, and chamfer. We're going to pick our direction. And then we're going to actually set our spacing all over again. So I do know that we could utilize the parameter table to set this. But aesthetically here, real quick, we're just going to go ahead and bump this up until we get close to what we want. That actually is fitting exceptionally well considering what we have going on. So let's go ahead and hit OK and create that into our profile. Given that our barrel nut is going to be sitting right here, we may want to change our mind a little bit later, but not a big deal. Actually, let's change that right now. Let's bump that down one just to be on the safe side. So another couple of cool things here is we could actually go back to when we extruded those. As you saw me do is I extruded those all the way down. Maybe we don't extrude them all the way down. Maybe we only extrude them a little bit so that these are now pockets. They're not all the way through the handguard. Again, we're giving it a little different view one way or the other. So now with that being said is we could repeat the process on the lower part. We can keep everything where it is. It's all up to you. But I'm going to jump forward here a little bit. And we're actually going to take this entire half and we're going to mirror it because we've done one half. Why not mirror one half over to the second half, right? So again, we now have our first half, our second half. And just like that, you're seeing that entire handguard come through in profile design from one side to the other. So I'm going to go ahead and actually take a step back here to where we did our extrude. I prefer the look of them being punched all the way through and running down the entire length of the handguard. So again, we've done our one side, our couple of our sides here. We've created a unique profile for that handguard. I think at this point we could start to clean it up and do some different things, but it's all in the eye of the beholder in my opinion. So let's go to the bottom here. Again, we could actually create our sketch along the bottom. I need to go ahead and create a center line just to make life easy. So we're going to go ahead and create center line, construction line. And then what I'm going to do is I'm actually going to use a project to give me possibly where my first pocket is based on that actual lower profile. So as you can see here, I projected that line down for my rectangle. I can now go in. Again, I went ahead and finished sketch too fast. We're going to edit that sketch, create my rectangle from center. And in this case, we can go ahead and drag that out as we've done before. We can actually create constraints based off that as well. So I'm going to go in and say horizontal, vertical. Some of you are probably asking yourself with the fact that I actually just did the one straight edge. I didn't include the fillets. You could include the fillets with what you're doing. So again, let's go ahead and extrude this. Create that profile, and we're looking good so far. One more time with the pattern feature or the fillets, just to give this that solid, clean design at the bottom. But as you see me do, I have to keep doing these fillets. They're repetitive. So one neat thing I could do actually at the end of the day is based on when I created my fillets up here, is if I click them, they actually show up in my timeline. So at one point I did the fillet and the chamfer on that pocket. But then I also patterned that. So if I grab these three items and I actually slide them back in my timeline, there is a point where I can move them so far back that I could actually utilize those for something that we're doing, right? So in this case, I created my sketch and my profile down here based off projection. Let's go ahead and delete that. And then what I'm going to do is I'm actually going to slide up before we filleted everything. So if you bear with me real quick, let's create that sketch one more time. Let's go ahead and project those points of interest, right? And then because I want this to be nice and straight on the bottom of my handguard, I could make this a construction line, but we're going to move a little quicker here. In this case, I missed my midpoint to midpoint. So let's do that one more time. And then our rectangle on center. And a couple horizontal verticals. So as you can see here, we've aligned everything between the two. We have everything set. Again, we're going to do that extrude. And again, the reason why we couldn't move it past that initial sketch is because it was needing those fillets to create everything, right? So again, we slide it forward as we see here. We have our extrude. And then we went in and we actually did those fillets. So let's edit that fillet and let's throw a few more in to what we have going on. So again, we're going to go ahead and get this guy here, and then we can go back and edit the chamfer. Again, that chamfer is from when we chamfered the other pocket. So again, we edit that. We add in a second profile holding control. And then lastly, let's steal that actual pattern and bring through that second pocket down our part. So as you're going to notice, we have a little bit of an issue with our pattern here. So maybe that isn't something we can get away with, or we could actually modify that and fix whatever is wrong. So in this case, our actual issue is we're running into a feature on our part. So we could go ahead and, again, let's just undo that extrude from what we did. And now we could go back and create a second pattern altogether. So there is a couple different ways you could do that. Is we're going to go ahead and just simply say pattern and pattern it. Again, based on the feature. And then we're going to pick our axis. This time we're going to go both directions. So we're going to go symmetrical. And then if we actually add in an even number, if I drag one way versus the other, you're going to notice that we're actually getting that to only do one on one side, but two on the other side, right? So in this case, we're having an issue with the pattern because our fillets are all together. So I could go back and, again, is take those fillets and chamfers and everything off and recreate that profile. So moving on a little bit, we do need to actually clamshell this so that we can actually create our tightening feature. So let's go ahead and edit and create another sketch. I'm a big fan of rectangles, as you guys are starting to find out here, is once I have my center line, I could just very simply drop a rectangle from center, and I could drag out that profile to whatever I want it to be at the end of the day. And in this case, I like the idea of that being 0.125 wide. And once again, I could constrain this even more to make my life easy, but I like just putting some designs on paper long before doing anything. So there we go. We have that nice little clamshell design now. We could go back. We could actually add in a few holes on that. So again, let's create a sketch from the side. I'm going to create a couple of points. Again, you guys are going to love this because I'm just going to go in with a line to start this. And I like the idea of 3 bolts as we've seen in the actual photo. So let's go ahead and get these 3 placed roughly where we want them. And then using that sketch, we can actually pick those 3 points to create our whole features. So we know those are going to be counterbores. We could probably sneak in there a clearance hole, and let's go ahead and do a M1.6 is a little undersized. M6 is a little over. Let's see what an M4 looks like. So an M4 is close. I like that. That's actually looking pretty good. So we went ahead and actually went too deep with that guy. So we can go back and edit that. So maybe an M4 isn't adequate, or we may actually want to do ours as countersink style. So again, we could go with that M4 design, a little too big. Let's go M3. You could actually also utilize standard dimensions for threads as well. But as I've created that clearance all the way through there, I can now use the thread feature to match those actual threads. So again, we're going to go in and we're going to create threads now. And what this is going to automatically do for me is it's actually going to give me my minimum tap drill size to drill these out. So again, we'll go to that metric profile. That's a 3mm hole, M3 by 0.5, which was the same as our screw. And now we created that actual spot drill and drilling cycle at the bottom. So I'm going to go ahead and fix this pattern down here at the bottom. That's going to drive me absolutely loony without fixing it. So let's go back and break these things up a little bit. Again, the hierarchy of our design tree is what's actually causing those problems, because we've kind of taken this step by step. But if I was to redesign this from scratch, there's a lot of things I could do differently to actually cut down on how much time and how much effort it takes to design this part. So there we went ahead and removed those 2 features. I'm going to go in and we're going to recreate those with simple motions. And then let's go ahead and get this end and our final end. We're going to go ahead and drag those out. We could type in critical dimensions if we knew them, or if we wanted to change those on the fly. But again, we're just going for a rough idea and to see what we could really get away with as an idea for sales. So again, we got that pattern set. Let's go ahead and do our feature pattern of our 2 pieces and our extrude based on our axis. Symmetrical. That is the wrong direction, so let's go back the other direction. It looks like I actually pulled in a extrude that was not the right extrude. So let's go ahead and pull in that other extrude here real quick. So we need this guy as well as our other 2. There we go. And again, we're going to go ahead and add in our 4th. And we know that spacing is -2.3. So again, we did our key mod on the bottom. We did our key slots on the sides, or I shouldn't say key mod. They're actually M locks nonetheless. But we actually placed all of our parts and started to build out this handguard as simple as possible. And as you can see here, that's kind of where I'm going to go ahead and stop with this at this point. Again, I would like to bring up the fact that we did have an outstanding sponsor reach out to us, Richardson Metals Inc. Feel free to reach out to these guys. Their contact information is down below. I know next week they're going to run a small batch of about 35 1-foot segments. You're able to buy these segments for you guys to test these out and run with them. I know this batch is going to be 70-75, which is a little more fun. And they're planning on running another batch a little later out of 60-61. Neat thing is these guys, just like ourselves, they're actually going to be at SHOT Show this year. So they're going to be over in booth 52101. As for us, we're actually going to be, as you can see up here at the top, we're going to be in a little different booth location, but we're actually going to be in EX328. So I know we're going to have product in each other's booths. We're going to be able to talk to each other's customers. We'd love to see you guys as you come out. Last and final thing before I go ahead and shut this down is, as you can see here, we actually have a giveaway between now and SHOT Show. All we're asking you guys to do is follow us on any of our social media, like a post, and even tag a friend. Every time you guys do this, you go ahead and get entered into a chance to win a mug, t-shirt, and a set of actual bottle openers. They're pretty neat. They're stamped out. But there's a couple combination of different level prizes. One of the big ones is we're actually giving away a post processor for the cam side of Fusion 360. Again, thank you.